Today we are doing 6.1.4 and talking a little bit more about inequalities. So in this first table we see that there are three different ways of representing inequalities. One would be in symbols, one would be in words, and one would be as a graph. So we're going to go ahead and fill in the other two representations given the one that's given. So this is in symbols, which means in words, this is the less than symbol. X is less than -1. This is what it looks like in words. As a graph, we learned in a previous lesson that we put the boundary point. Here's -1. And since -1 is not less than -1, we don't shade it in. And -2 is less than -1, not 0, because we do the test to see do we go to the left or to the right. And these are the numbers that are less than -1. That's the solution. The next one, we have x is greater than or equal to -2. So here is the x greater than or equal to, looks like this. And 2 is our boundary point. Okay, so that means at 2, we're going to put our circle. And since 2 is greater than or equal to 2, because it's the equal part that makes it true, that means that 2 is a solution. And then, is 1 greater than or equal to 2? No, 3 is. So we are going to the right. And then on this last one, we have a graph. So what does this graph say? Okay, and those are the numbers that are greater than -3. So x is greater than -3. Since it's not shaded in, it's not or equal to. Okay, so this is x is greater than -3. So in this next part, we're going to be graphing and writing a symbol, an inequality, using x or m or l or y, whatever it calls for. So in the first one, a speed limit on certain freeway is 65 miles per hour. So x equals any speed that can get a speeding ticket. So here's x. What would be our boundary point? Okay, so the boundary point is 65. Now, any speed that can get a speeding ticket, would it be below 65, above 65, or equal to 65 as part of it? Okay, so you can get a speeding ticket by going above 65. Will 65 get you a ticket? That would be no, so we would not put or equal to. So when a speed limit is posted, you can go that speed limit. So to graph it, let's go ahead and put the boundary point in the center, and then just put a couple of numbers on either side so that we can make sure you know how to make a number line. Okay, so these are all speeds greater than 65. So that'd be an open circle at 65 and to the right. Okay, that would get you a speeding ticket. So all of these are solutions. Okay, so on the next one, you brought $10 to the mall. Let y represent any amount of money you can spend. So we have our y, and then our boundary point is 10, because that's $10. So the amount of money that we can spend, less than, greater than, less than equal to, or greater than or equal to, 10. Well, if you have $10, you can spend less than $10, definitely, but you can also spend $10. So that would be y is less than or equal to 10. So then 10 would be our boundary point here, and then we make those other values just to show that's a number line. Okay, and then 10 is our boundary point. We are shading it in because 10 is a solution. We can't spend $10, and it's all of the values below 10 that we can actually spend. You cannot spend $11 if you have $10. All right, and then this next one, to ride your favorite roller coaster, you must be at least 5 feet tall, but less than 7 feet tall. Let h represent any height that can ride the roller coaster. All right, so here is our h. Now, you need to be at least 5 feet tall. So what does 5 mean? That means 5 is a boundary point. But then you must be less than 7 feet tall. So what this actually means is there are two boundary points. We have a 5, and then we have a 7. So how do they relate to the height that can ride the roller coaster? Well, the 5, you must be at least 5 feet tall. So does your height have to be higher or lower? Your height has to be higher. So that's going to go in this direction. Can you be 5 feet tall? At least 5 feet includes 5 feet. 5 is the minimum. And then if you look at the height, it says you must be less than 7 feet tall. So that one, your height has to be less than 7 feet. So that H kind of falls in the middle of those two. So since we have two boundary points, that means that we are going to have two circles on our graph. So here is 7, 8, 9, and then 6, 5, 4. Okay, so our first boundary point is 5. And our second boundary point is 7. And our solutions are all of those in between, but which of these two is included in our solutions? It's 5. Because 5 can be a height. Okay, so you can be 5 and you can be everything below 7. This is the graph for that one. Here in our next problem, we have Ellie who's working on a dollhouse, and she has two different size boards. A long board is 13 inches. The length of the short board is unknown. She puts 3 short boards end to end and then added 4 inches. The total length was still less than 13-inch board. So let's draw a picture of this, how the short and long boards are related. So first, kind of like the 5D process, we have to draw it. So let's first draw 3 short boards end to end. So here's a short board, another short board, and a third short board, end to end. And then we're adding 4 inches to it, so there's a little extra space, which is 4 inches. Okay, now since we don't know the short boards, it says it's unknown, we can go ahead and call those X. Now it says that the total length of this is still less than 13-inch board, so we're going to draw that 13-inch board here as it relates to it, and it is longer than. Okay, so this is our 13-inch board. So this is a picture of the relationship of the two. Now what we're going to do is we're going to write an inequality based on this drawing. Okay, and the inequality, remember, has a less than, greater than, or equal to. Okay, inequality means this, this, or this, or this. These are inequalities. Okay, so first thing, we know that the 13 is greater than or less than. 13 is greater than. And then our short boards and the 4 inches, we're going to represent them with an expression that would be 3x plus 4. Another way we can look at it is we can say that the 3x plus 4 is less than 13. 3x plus 4 is less than 13. Because we know that the 13 is longer, it can go either way. We can use either inequality. Okay, so what are possible lengths of the short board? So now we're going to come up with a solution or two so that we will be able to graph this. So show your answer as an inequality and on a number line. So first, before we graph it, let's put that inequality here. We have 3x plus 4 is less than 13. Okay, now, when we're looking at our inequality as two separate mats, mat A and mat B, that we're comparing, okay, we can kind of use that as kind of like a comparison mat. We can see that they're both simplified, but we can start taking away something from both sides. What can we take away from side A and side B? We can take away 4. And once we take away 4, we now have a new expression. We now have 3x. And then on the right side, we still have 9 left here. Okay, and they still, since that was a legal move, they have the same relationship. That did not change the relationship between the two. So 3 times what is less than 9? What value can this x be? Okay, so let's pick a value. Let's pick 5. Okay, can x be 5? 3 times 5 is 15. Is that less than 9? Can't be 5. So let's try a smaller number. Let's try 3. 3 times 3, is that less than 9? 3 times 3 is 9, so that does not work. And then you realize, well, since 3 times 3 is 9, this must be less than 3. So this number here needs to be less than 3. And we would see if you plug in 2, that would work. All right, so here's our inequality. X is less than 3. So that means that those short boards need to be less than 3 inches. Otherwise, they would be the same as the long board. So here's our number line. And we're going to put the boundary point. We're going to put a circle. Is 2 a solution? 2 is less than 3. It is. So that means we are going to go to the left, because 4 is not less than 3, not a solution.